And if you look in the fine print, this is good advice for young scholars, always look in the fine print of the method to see precisely what people are doing. And if you look in the fine print of, for example, the Vine et al. Study, you find that they made a certain coding assumption. In our mock jury studies, we don't let people say, be undecided. You have to make a choice. And they say, well, it's really hard. I'm not really sure. Go ahead. You have to make a choice. Whereas in actual juries, of course, jurors sometimes say, I'm really not deciding. I'm not willing to take a stand. I'm not willing to vote. And they'll say, I'm going to abstain for this first ballot. Well, what they did in this and every single one of those field studies is they made a simplifying assumption. They said if people took an undecided position, we assumed that they were for not guilty. Now, I think that that is at least arguable as a plausible assumption. If people say, I really can't decide one way or the other, their assumption is that they all really, if you force them to say, not guilty. Whereas some of them may have said, well, if you force me to, I guess I'll say guilty. So we thought, in fact, a more reasonable assumption assumed about half of those people would have gone one each way. Right? Now, the net effect of that assumption is to produce a tilt in those initial splits. And here's a little illustration. Suppose you had a 12-person jury where there were 6 people for not guilty, 2 people for, 2 for not guilty, 6 for guilty, and 4 who were really undecided. I'm taking an extreme example here. Under their coding, what that would be coded as is an equal split jury, one of these critical 6-6 deliberation. But I think it's a more reasonable assumption if you split them 2-2 here, that that's an 8 for guilty, 4 for not guilty. Or if you drop the 4 undecided altogether, you still have, of those willing to take a stand, a strong preponderance for guilty. So what they're saying is that at least some of their equal split groups are ones where, in fact, I think under more reasonable assumptions, there's a strong majority in favor of conviction, and would we then be surprised if their final jury outcome was a conviction, and that's the pattern that they tended to find. Right? So, that's what I just said. So, what we thought of is, what if we can go back and recode those data without that assumption? And we were able to get our hands on the data for Devine et al., one of these 4 studies, the 2004 study. And we could identify those who were abstains or undecided, and then recode them. And what happens when you do that? Well, this first thing is the matrix of their decisions under their assumption that the abstains and undecideds are all not guilty. And the key row, again, is that 50-50 split, and they find that 5 of 6 groups that do manage to reach decisions are convictions. What happens if you make this alternative coding assumption? You get only 3 groups, 1 hangs, and you get 1 that convicts and 1 that acquits. So we got a really tiny sample, and it's rather hard to draw a screen. But at least the trend is, as we thought, is you're getting away from this bias towards conviction towards something more nearly the other way. Now, what Jim Davis did in a lot of his research is to try to capture the entire process of group decision-making in matrices like this. And my colleague, Rob McCoon, in a soon-to-be-published psychological review paper, has said that we might also do this in interesting graphic ways. He's got a model he calls the BOP model, and one version of it is the BBOP model. And its basic assumption is that as the proportion of people in groups are going one way or the other, that there's a curve that describes it, and there's a threshold where a certain number of people for something is hit, and then you get rapid change. I'm going to show you the application of that fit to the old data with the old coding and the new coding. So here's, let me walk you through this quickly. This is the proportion of jurors at the beginning of deliberation in favor of conviction. Right? The red dots are the data from Devine et al. If you make their original coding assumption. If there was perfect symmetry in this, there's a parameter in this model, it's the B parameter, which is where does the break come? Where's the threshold? That green dotted line is one with perfect symmetry. Just put it in there just to show you what that would be like if there were perfect symmetry. In this particular data, when you fit it, the B is 42.2 less than 50. What that means is there is an asymmetry, but it's in the direction of conviction. Majorities for conviction are more powerful than majorities for acquittal. And that's the summary that they came to in their data. Another way of looking at that is if you look on that green middle line, what happens when you start with an even split? The best estimate is that if you start evenly, that you're going to have about a 2/3 probability of convicting, not acquitting. That's biased towards the pro-conviction direction, right? So you see this clear asymmetry, but in the direction of severity, not leniency. Now what happens if you recode the data with the assumptions that we talked about, where undecided and abstains are split equally between the two factions? What happens is that the best fitting model is one where the B value is now on the other side of equal split. You have an asymmetry, but now it's a leniency asymmetry, the exact kind of asymmetry that popped out of those first dozen or so experiments that we talked about earlier. So, summary. This asymmetry that appeared in lots of the early research, in the field research, may be due to a coding artifact. And I think that we can make a good empirical case that real juries act like these mock juries and they do what they're supposed to do. Now, let me take my last few seconds to say a few words about this fellow, James H. Davis. His name has been popping up here a bit, as you might expect it would. But in lots of areas in this field, I think you'll find the same kind of pattern. Jim popularized the social psychological analysis of jury decision-making back in the 1970s. And any modern research on juries would almost certainly talk about his work. He had the first experimental evidence for this asymmetry long before any of the rest of us recognized it. He recognized it. And he recognized that it wasn't a bias. He didn't use the word bias. He called it a defendant protection norm. And the law functionally has such a norm. It says that if we're going to make mistakes, it's going to be in a certain direction. He also provided an analytical model, a structure for us to both identify these kinds of asymmetries. And it turns out, as you've seen earlier, for example, truth wins in intellectual problems are a nice example of these strong asymmetries, give you some insight into the nature of how people think about problems and persuade one another about those problems. So those of us who've come to SESP for many, many years are going to miss this man. His good humor, his sparkling wit, his excuses every year for why he lost the Davis Cup. There was a tennis tournament here, and he would give the award out and explain to people why another travesty had occurred, and it didn't go to its true namesake winner, but went to other less deserving person. But it's not just that we're going to miss. I hope this talk shows we're going to also miss this keen intellect, the elegant prose that you saw in his work, and the many insightful contributions that he made to the study of group processes. So, I thank you.
One of the niceties of going last in this particular symposium, they've already explained most of the things that I would have to go through to explain things about asymmetries and decision schemes and all that kind of stuff. And as you will see, I've actually borrowed a number of ideas from the people from before me here. But what I'd like to talk about today, plus I also want to let you know that my co-authors on this paper did not show up on the screen. Christine Smith and Amanda Lakeland-Anglade and Katie Klua are all co-authors. Also, one interesting note, they make a nice lineage from Jim Davis, because I worked originally with Jim, and Christine worked originally with me, and Amanda worked originally with Christine, and Katie originally worked with Amanda. So, it's a nice sort of tribute here. But what I'd like to talk about today is how some of these modeling techniques I've used to sort of look at when groups do well and when groups don't do so well. And sort of the standard sort of lay interpretation of group decision making, and in some cases also more social psychological analyses, is that when groups do well, it's usually because they used a good process. But there's a lot of evidence that groups can often be good. They're better problem solvers, better decision makers, and wisdom of crowd. We're not as good as honeybees, but we're close. And, but there's also instances where groups aren't so good, where seemingly intelligent, well-meaning experts made really silly decisions that had very bad outcomes. And quite often, the basic premise, or the way people understand this, is if the group made a good decision, they used a good process. And good process usually means you've thoroughly discussed all the alternatives, you brought up the appropriate information, those key pieces of information came together, and the group chose the optimal, or at least a satisfactory response. When groups don't do so well, it's because they used a bad group process, where they have an overbearing leader, or they felt invulnerable, or they didn't consider all the alternatives, they didn't bring up enough information, they reached consensus too quickly, etc., etc. And so the basic idea is that when we have a bad group decision, it's because of group thinking. And this has become a very common term. You see it in almost any write-up in the newspaper about a decision that went bad, that had anything to do with the group. It's because they suffered from group thinking. Well, what I'm going to argue is, basically, I don't think so. I basically think that most of the time groups do neither of these two things. They do some of them, but very rarely do they really take all of the information into account and look at every alternative. It's just in many situations, they don't really need to do that to end up at the right spot. But there are other situations doing exactly the same thing where they end up in not such a good spot. And it's hard for them to know a priori which of these things are going to work. Okay? So I'm basing this in part on the notion of social sharedness, a concept that I co-opted from Tatsuya a number of years ago. But it's basically the idea that things that are shared among the group members at the beginning of the group performance situation are going to have an inordinate influence on where the group ends up. Okay? You can see this quite clearly at the preference level. And we just talked about, like, you can do a very good job of predicting where a jury is going to go by knowing what the preference structure at the beginning of deliberations were. If most of the people were tending toward guilty, the group is going to go to guilty. Most of the people are tending toward not guilty, they're going to go toward not guilty. Now you put this into a performance situation, and what we can see here is if we assume that alternative A, that's the one we're predicting here, if you assume alternative A is the correct answer in a simple majority decision process, anytime that most of the members are doing okay on the task, so on average they're better than 50-50 likely to choose A as an individual, the groups will actually outperform individuals. Their average performance will be better than the average individual. And so there'll be this enhancement effect. But if most of the members are favoring the wrong alternative at this point in time, when you bring them together in a group, it actually goes in the other direction. The identical process, simply going with the largest faction and letting it win, ends up going in very different directions depending on where that biggest faction is leaning. Okay? Now, another aspect of this, and this is what I'm going to focus on a little bit more for the other data that I'm going to show you, that was make-up data, by the way, I wasn't going to do a study or anything, is that members also share a certain set of cognitions when they go into a group, maybe based on information they have, or shared experiences, or just sort of a way they sort of look at this particular task. But these shared cognitions tend also to have an impact on how the group reaches its final consensus. And what happens is the things that everyone in the group knows or feels or thinks about a particular task makes it easier to justify alternatives that fit those sort of shared experiences and cognitions. So if someone comes up with an alternative and it seems plausible and most people kind of go, yeah, I can see how that works, they'll go for it. They'll move in that direction. And what I'm going to argue is that these exact same processes work well in situations where the average group member comes in with a basic representation of the task or their shared experiences are in fact accurate, or accurate enough that most of the people will find plausible the correct answer. But there are situations where the most plausible answer actually isn't the correct answer. And you see the same types of processes working here, but now they're going in the wrong direction. This is